Good morning, everyone. So today we will go for module 5, that is automotive emission control system and emission standards. So whenever you talk about emissions, especially from automotive, there are several emissions will come out from automotive, which will cause environmental hazards and human health effect will be there. So we want to study briefly about how we can control that emissions coming out of from the IC engine, and also we have to study the standards enforced by the government. So if any new vehicles comes out, it has to follow that standard. So these are the things we are going to study in the module 5. So syllabus, so emission control system, different air pollutants, formation, photochemical smog, causes, automotive emission controls, controlling of crankcase emission, controlling of evaporative emission, exhaust gas cleaning, controlling of air fuel mixture, controlling of combustion process, EGR, treatment of the exhaust gas, air injection system, air-aspirator system, and catalytic converter. These are the things we are going to study in the syllabus, and then the emission standards will be there, that is Euro 1234 norms. So respectively Euro, we have the bar stage 234 norms and a motor vehicle act. So this nowadays April 2020 onwards, we are moved towards the Euro 6, that is para stage 6 norms. We have skipped the 5 norms, so directly we move on to the 6. So now new vehicles whatever coming, that is according to the bara stage 6. So now onwards we have to follow bara stage 6 also. So this part, that is emission standard part, that is assignment for you, so you have to include bara stage 6 also. Okay, now we will come for the introduction part of the automotive emission control technology. Before that, we should know what do you mean by pollution, all those things. So day by day we can see there will be the lot of increase in the vehicle purchase. So many exhaust will left out in the atmospheric. So whenever you say about emission, so the exhaust coming from the ICE engine, in that so many components will be there, in that what particular component will cause major hazards in environment, or which will be effect on your health issues. So all those things we have to study that one. Okay, so now ICE engine, which will be powered vehicle, ICE engine powered vehicle have come under heavy attack due to various problems created by them. The most serious problem in the ICE engine is the air pollution, where the main problem is developing countries like India, which will faces several problems of pollution in their metropolitan city like Delhi, Bombay, Bangalore, Madras, Kanpur, etc. So a lot of pollution will be there. So first of all, what do you mean by air pollution? So air pollution can be defined as addition to our atmosphere of any material which will have a deleterious effect on the life upon our planet. The main pollutants which will comes out from the automobile are carbon monoxide, that is CO, then unburned hydrocarbon UBHC, or called simply HC, then oxides of nitrogen. These three are the major pollutants, air pollution, which will caused by the your automobile engines. And other will be there, that is lead, particulate emission, all those things will be there. So that might be lightly in the light manner we will have the pollution. But the three major pollutants which is coming from your engines, that is CO, HC, and oxides of nitrogen. So automobile are not only the source of air pollution, other sources also is there, like electrical power generating plant, industries, domestic fuel consumption, refuse burning, then industrial processing, etc. They are also contributing emission in the environment. But now when we study about ICG, then these are the things we have to consider. Okay, these are the emissions. So we can say that it is estimated that in USA alone, in USA alone, 200 million of ton man-made pollutants add to their air. Therefore, this pollutant, if not controlled, adversely affect our health. Okay, and automobile manufacturers have been working towards this reduction of these pollutants whenever the auto emissions were found to be part of the cause of photochemical smog. One of the reasons where you can see this kind of effect in metropolitan city like Delhi, you can see sometimes visibility will be not there. So these are the causes of emissions, especially the burning of the agriculture product will be there in the Punjab. So due to that, visibility in the Delhi it is affected. So these are the pollutions will be there that has to be. Whenever you talk about IC engine emission, so I told three major pollutions will be there. One is the SC emission, then one more is the CO emission, one more is the NOx, that is oxides of nitrogen. Okay, now we'll come to our hydrocarbon emission. So hydrocarbon emissions, how exactly it is formed? This is nothing but unburnt hydrocarbon itself. That is the fuel present whenever fuel is burned. So 100% fuel cannot be burned inside the combustion chamber because of so many factors. Residence time will be there, and availability of oxygen, temperature, combustion chamber design, air fuel ratio. So many aspects will come into picture. So due to this, all the fuel cannot be burned inside the combustion chamber. So some fuel will be unburned will be there. So that will cause us hazardous to the environment. See, these unburned hydrocarbon emission are the direct results of incomplete combustions. The pattern of hydrocarbon emissions are closely related to design and other operating condition. Two of the important design variables are induction system design and the combustion chamber design, while main operating variables are air fuel ratio, speed, load, and mode of operation. These are the things it will form the hydrocarbon emission. Okay, design of combustion chamber, that is a very important factor because we want to make sure that all the oxygen it should be available for fuel, so that we have to achieve more number of combustion, means 100% of combustion we want to achieve, so that combustion chamber design will be very much effective. Okay, so this hydrocarbon emissions will be different for different engine, like a gasoline engine will have different kinds of hydrocarbon emission. In CI engine that will have a different kind of emissions. So in SI engine up to 600 ppm 6000 ppm of hydrocarbon components will be there, which is equivalent to 1 to 1.5% of the fuel. About 40% of the sunburned gasoline fuel components. The other 60% will have the partially reacted component that were present in the original fuel. Okay. Uh, this consists of small molecules which are formed very large molecule break up thermal cracking during the combustion reaction. Okay, the make of SC emission will be different for gasoline blend depending upon the original fuel component, and combustion chamber geometry engine operating parameter also influences the HC component. And hydrocarbon emission get into the atmosphere which will act as irritants and odorant, and some are carcinogenic effect will be there on the hydrocarbon. Okay, all the components except CH4 in react with the atmospheric gases to form the photochemical smog. So one of the major contribution for the photochemical smogs are SC emission also will come into picture. Now, what are the causes of SC emission? First one is non-stoichiometric air fuel ratio. So, what I mean by stoichiometric, it is the chemically correct air fuel ratio required for the combustion of the fuel. Theoretically, how much air is required for 1 kg of fuel. So, that is nothing but the stoichiometric air fuel ratio that will comes by chemically balancing the fuel with the oxygen or air. So, we will get the theoretical how much air is required. So, this is theoretical stoichiometric air fuel ratio, but actual case we won't achieve that stoichiometric air fuel ratio. Either we will have sometimes we will have the more air, sometimes we will have the less air. Or means we will have the lean mixture or a rich mixture. So here we can see figure. We can see as the x-axis we have the equivalence ratio, which will define the alpha ratio actual by stoichiometric fuel air ratio. So that is the ratio equivalence ratio which will tells about whether it is lean mixture or rich mixture. So one is your stoichiometric, that is the chemically correct equation. Left hand side of one, it is a lean mixture where more predominant air will be there. Right hand side, it is the rich mixture where the fuel concentration is more compared to that of your air. So in this is called as non-stoichiometric. This is also called as non-stoichiometric. Exactly at one, it is called as stoichiometric. See, you can see in the graph what will happen, sir. As equivalence ratio move towards the richer mixture. See, as moving towards the richer mixture, your SC emission formation is keep on increases. So it will be least in the leaner region, say around 0.8, 0.7 region, you will have the lesser SC emission. But as soon as you cross that 0.8 or 0.85, so SC emission formation will be more. So if it is crosses 1, that is in the richer side, then more SC emission formation will be there. This is because in the richer side the fuel concentration is more, the availability of oxygen is less, hence combustion may not happen completely. So unburnt hydrocarbon formation will be huge in the richer side. Okay, this is about SC emission. Whereas other concentration also you can see in the leaner side because availability of oxygen is more, hence emission is less for CO, NOx and SC. Okay, but as you move towards the richer side, what will happen? As you move towards the richer side, the availability of oxygen will become lesser and lesser. So your fuel concentration is more, hence only CO will be formed. CO2 won't be formed because first in combustion, carbon will react with the oxygen. So first it will form CO. Then if more oxygen is there, then the complete combustion. CO will again react with the oxygen, then it will form the CO2. Hence, availability of oxygen is very important, so that CO formation will be more if it is non-availability of oxygen is there. So hence this is about CO emission. And NOx also we can find peak around 0.95. 0.95 we can find the NOx is more. Then after it is moving towards rich, NOx formation is less because availability of oxygen is less and the combustion temperature also decreases. Again in the linear side same case, in the linear side oxygen is there but combustion temperature is decreases. But in the when you look into this graph, we can say in the linear side it is operating in the linear side is always good to in the emission point of view, but linear side won't give that much of power. That is the major issues because in the vehicle, whenever you talk about vehicle, then we need to have the more power, then only the customers will satisfy with respect to power. So power availability will be less, and they will go for slight richer region only, but in the slight richer there is the problem of emission. So now emission has to be controlled. So now this is about SC emission, that is on the richer side. Due to unavailability of oxygen, with the formation of SC emission will be more. So this is richer side, usually more richer will be there during the startup of the engine, because it has to start, so more fuel is be introduced, and the SC formation will be more in the during the startup case. Then when it reaches particular speed, then it will comes to the linear side, and SC emission formation will be less. And once again, when you require more power, again more fuel will be supplied, and formation of SC will be more. So this will depends upon type of loading condition on the road. So this is SC emission mainly depends upon your air fuel ratio. One of the factor will be your air fuel ratio. Okay, next SC emission, we will go for SC emission. This is another way. So same thing, NOx in the linear side, how it will be there for your diesel engine. Diesel engine, around after point 0.8 it will give shoots of like anything. So this is for diesel engine, earlier is for SI engine. So shoots of like anything in a diesel engine after point 0.8, because diesel engine always it will works in a linear region, because more amount of air will be supplied because of heterogeneous mixture case, since more amount of air will be there. So always it will be the linear region itself. Richer region we won't find in a diesel engine. Next parameter for causing the SC emission is incomplete combustion. So incomplete combustion means when the fuel and air entering into the engine at the ideal stoichiometric mixture, perfect combustion does not occur in the actual case, and some hydrocarbon will end up in the exhaust. So there are several causes of this incomplete mixing of the air and fuel, results in some fuel particle not finding the oxygen to react with. Then flame quenching at the wall. Flame quenching means a flame will be traveled, and at the end of well it the flame will quench, which will leaves the small amount of unreacted air fuel mixture near the wall, and the thickness of this unburnt layer is in the order of tenth of its mm. Some of the mixture near the wall it doesn't originally get burned, as the flame from passes will burn later in the combustion process, as additional mixing of occurs due to swirl and turbulence. Another cause of flame quenching is explosion, which occurs during the combustion and power stroke. So this will be another cause of flame quenching, and hence SC emission is formed. So as the piston moves away from the TDC, explosion of the gases lowers the both temperature and pressure within the cylinder. This slows the combustion and finally quenches the flame somewhere in the power stroke. So this is another reason of quenching of the flame. So quenching of the flame will result in your SC formation. So this leaves some unburned hydrocarbon or unreacted hydrocarbon. So high exhaust residue causes poor combustion and greater likelihood of expansion quenching. So these are experienced at a lower load and idle condition, especially incomplete combustion or SC formation is more during the idle condition and lower load. And particularly in the cruising load, we won't get much of SC emission. So very lightly emission will be getting at cruising condition. So then if we have adopting the EGR system, then high levels of EGR will cause us more amount of SC emission also. And it has been found that SC emission can be reduced if twin spark plug is added in the combustion chamber. That is the one of the new technology you can see in the Pulsar. We have the twin spark technology they have adopted in the bike. Why they have adopted? Because for complete combustion of fuel, and so more power can be obtained. Okay, and one more reason is for complete combustion of fuel will occur, and SC emission can be reduced by using the two spark plug in the combustion chamber. So by starting the combustion at two start point, flame traverse distance means it will cover flame will cover all the fuels, hence more amount of fuel can be burned. So this is about incomplete combustion. Next we will have the crevice volumes. So whenever you talk about crevice volumes, so crevice volumes are nothing but during in the piston and your cylinder liner, there will be a small gap will be there, so that volume is nothing but your crevice volume. So between your rings and piston, between your rings and piston, small gases will be there, so gap will be there, so that is known as crevice volume. So during the compression stroke, what will happen? Early part of the combustion process, at the end of compression stroke, before starting of the combustion, air and fuel will be compressed into. Whenever the air and fuel is compressed, some of the amount of air and fuel will be there in your crevice volume. So this volume, some of the amount will be there. Okay, as much as means 3% of fuel in the chamber can be forced into this crevice volume. Okay, later the cycle, during the expansion stroke, during the expansion, that is the power stroke, pressure in the cylinder is reduced below the crevice volume pressure, because this crevice volume, first initially during the compression it is going, so it will be having a higher pressure. So during the power stroke, pressure is reduced, so this will be the higher pressure. So this volume will comes in, this volume of the fuel will comes from this crevice volume, then it is going to your combustion chamber. So there it will form the SC emission, unburned hydrocarbon it will form, because during the power stroke it will comes out, so that will cause us the SC emission. So this is the one of the thing we have to take care, that is the crevice volume. So up to 88% of the all the emission can be coming from this crevice volume. Remember, up to 80% of SC emission, it is caused by this crevice volume source. Next we have the leak past the exhaust valve. As the pressure increases during the compression and combustion, some of the air fuel is forced into the crevice volume and around the edges of the exhaust valve also. Not only in this crevice volume, near the exhaust valve also there, of course, and between the valves and the valve seat will be there, exhaust valve and valve seat. There also it is trapped. A small amount of even leak past valve also into the exhaust manifold. Because of that, unburned hydrocarbon will be there in this between valve seat and valve. So during the exhaust stroke, that fuel will goes like that without burning. So that is also possible way of causing the SC emission. Next will be the valve overlap. So valve overlap, already we know valve overlap is nothing but it is the time duration where both intake valve and exhaust valves are open. So this is some duration we will have the both the valves are in open, so that what will happen, due to this fuel is coming inside the intake valve, so this will directly it may go into the exhaust, so without burning we are going, so that is known as unburned. So that is also source of your SC emission. So well, if you want to minimize this emission, then the valve overlap timing should be optimized. So this already you have studied in the last class. Next, deposition on combustion chamber valves. So this is one of the another source where SC emission can be formed. So we know that gas particles, including the fuel vapor, are absorbed or deposited on the walls of combustion chamber. The amount of absorption is a function of your gas pressure, so maximum occurs during the compression and combustion. Later in the cycle, when the exhaust valves are open, the cylinder pressure is reduced, absorption capacity of the deposit material is lowered, and gas particles are deabsorbed back into the cylinder. So these particles, including some SC, are then expelled from the cylinder during the exhaust stroke. So this problem is greater in the engines with the higher compression ratio. Due to high pressure this engine can generate. More gas absorption occurs as pressure goes up. Clean combustion chamber valves with the minimum deposit will reduce the SC emission in the exhaust. Most gasoline blends, including additive to reduce the deposit buildups in the engine. Older engine will have typically have a greater amount of deposit buildup and corresponding increases in the SC emission. So this is due both the age and less swirl that generally found in the earlier engine design. So for this, to avoid ice swirl is provided. So whenever the ice swirl product, the SC deposition will be reduced. So these are the another causes of formation of your SC emission. Next one is oil on combustion chamber wall. So a very thin layer of oil, that is your lubricating oil, it will be deposited on your cylinder wall of an engine. So which has to provide lubrication between your moving piston. So during intake and compression stroke, compression, the incoming air and fuel comes in contact with this oil film. So what will happen during the combustion? Again, that oil will get burned, hence the formation of a formation will be there along with that fuel. So this formation of AC due to oil combustion, it is very little. So this will increases based upon oil consumption rate. If the oil consumption rate is high, then AC emission formation also very high. So this is are the sources of your SC emission. Next we will go for carbon monoxide. Carbon monoxide, it is colorless, odorless, poisonous gas. It is a poisonous gas which will be generated from the engine whenever the fuel-rich mixture is adopted. Fuel mixture rich is adopted. So this formation is formed due to incomplete combustion only, because in this CO, the carbon present in the fuel, which will react with the oxygen, and it will form CO first. Then again that CO will react with the oxygen, then it will form CO2 and heat. So this is how the combustion will take place of the fuel. But if availability of oxygen itself it is less, then our air fuel mixture is in a richer region because of insufficient oxygen as well as insufficient time. Two conditions are there over here, formation of CO. One is insufficient oxygen, one more is insufficient time. Because of that, incomplete combustion will lead into formation of your carbon monoxide. So theoretically, the gasoline engine exhaust can be made free of CO by operating air fuel ratio which will greater than 16:1, that is in the linear side. However, it is clear from this one that CO will always present in the exhaust even at the lean mixture. So small amount of CO will be always there in the exhaust. We can't avoid 0% of CO. CO will be there because sometimes dissociation will take place, and so CO formation will be always there. So first we will have the carbon C plus O2, it will give CO plus O. That CO will react with the O2, that will give CO2 plus heat. So this will the process for complete combustion of the fuel, but in complete combustion maximum CO will be there. Okay, the percentage of CO that will increases in the idle range as well as in the lower load, because it will operate in a richer region. The passenger car CO percentage has been found as high as 7% with the rich mixture and 1.25% with the near stoichiometric. Carbon monoxide emissions are high when the engine is at idle and during the deceleration also it is very high. They are lowest during the acceleration process, that is when you reach a steady state of speed, then the formation of CO will be very less. Closing of the throttle valve will reduces the oxygen supply of the engine, which will causes main causes for CO production. So these are the how CO produce in the engine. If you want a well designed SI engine operating under idle condition, we have to exhaust mole fraction of CO as low as possible. In CI engine operate overall the mixture which will have the lower CO emission. Next we have the NOx emission, very important emissions nowadays, that is oxides of nitrogen. So oxides of nitrogen which may occur only in the engine exhaust are the combination of, remember it is the combination of nitrogen oxide, NOx, what you will call it, is the combination of nitrogen oxide and small amount of nitrogen dioxide. The in NOx major part is your nitrogen oxide, and small amount of NO2 will be there. So this is the two combination of these two, it is called as NOx. So how it is formed, because in the ice engine fuel will react with the air. We are not giving pure oxygen, we are supplying the air. So in the air majority component will be nitrogen, that you have to remember. So this nitrogen at high temperature, whenever the combustion occurs at high temperature, it will react with oxygen. So nitrogen plus oxygen, it will give NO plus N, and this N is again it will react with O2, again it will form NO plus O, and this N also it will react with OH, again it will form NO plus H. So this is how formation of NO will take place. There are three ways it will form the NO, that is one oxygen plus N2, next N plus O2, next N plus OH. So these three again it will give formation of NO. Now NO whatever it is formed, it is further react with oxygen or water, because water is the product of combustion, and NO again it will combine with water. So this will form NO2 and H, and this NO also it will react with O2, again it will form NO2 and O. So this is how your cycle will be, the formation of NO and NO2. So for this has to be happened, if NOx has to be formed, the two strict condition is, one is availability of oxygen, one more is high temperature. This all the reaction whatever it is formed, it is dependent upon the temperature and availability of oxygen. Therefore high temperature and availability of oxygen, high temperature and availability of oxygen are the two main reasons of formation of NOx. Remember, these are the two reasons, that is high temperature and availability of oxygen are the two main reasons for the formation of NOx. When the proper amount of oxygen is available at high peak combustion temperature, then the more NO is formed, because these are the three steps we can form the NO, then the formation of NO will be more, and NOx is formed with the atmospheric gas NO oxidize. The combination of HC and NOx, the combination of HC, that is unburnt hydrocarbon, and oxides of nitrogen in the presence of sunlight and at certain atmospheric condition, which will produce the photochemical smog, remember. So once NOx is formed, that is NO plus NO2, due to availability of oxygen at high temperature, once NOx is formed, NOx plus unburnt hydrocarbon in the presence of sunlight, it will form the photochemical smog. This is the main reason for formation of smog. This is the mechanism of smog. And the NOx concentration in the exhaust is affected by the engine design and vehicle operation. Air fuel ratio and spark advance are the two important factors which will form the significantly increases your NOx emissions. Okay, the maximum NOx is formed in the fuel ratio for SI engine in between 14:1 to 16:1. That is just near to stoichiometric, that is at lean and rich air fuel mixture, NOx concentration is very low. Just in the stoichiometric region we are finding the maximum NOx. and also increasing the ignition advance, which results in lower peak combustion temperature and high exhaust temperature. This will result in high NOx concentration in the exhaust. Okay, and nitrogen sometimes it will be there in the fuel also, and this will maintains a trace amount of NH3 NCHCN, but this will be contribute a minor degree. So these are the minor ways NOx will be formed. There are number of possible reactions will be formed NOx, that is already we are covered. So this NOx react with the oxygen atmospheric to form the ozone, and this is the one of the major cause for your photochemical smog. Next, photochemical smog. So as already told, NOx and HC are the two major source for your photochemical smog. So NOx is the main culprit for your photochemical smog, which has become major problem in many large cities in the world. Smog is formed by the photochemical reaction of automobile exhaust and atmospheric air in the presence of sunlight. Remember, automobile exhaust and atmospheric air in the presence of sunlight. So NOx decomposes into NO and monoatomic oxygen. So whatever NOx is there in the presence of sunlight, it will decompose, so deassociate. So and it will form NO and O plus smog. So this smog is very dangerous for the health issues. So monoatomic oxygen is highly reactive and initiates the number of different reaction, one of which formation of ozone, that is O plus O2, it will form a O3. So ground level ozone is always harmful for the lungs. Say this whatever ozone is formed in the ground level, it will be always harmful for the human health, that is especially for the lungs and other biological tissues. It is harmful for your trees, causes billions of dollars of crop each year, and damage also caused through the reaction of with the rubber, plastic, and other materials. Ozone also causes resistance from atmospheric reaction and other engine emissions such as HC, aldehydes, and other oxides of nitrogen. Okay. Next, emission reduction. So now the other emissions, how it will form. One is a crankcase, close to crankcase ventilation. Next, one more is your fuel tank and carburetor ventilation. Then there is the designing of engine, that is combustion chamber, cooling system, then fuel supply system, ignition system. Next, we will go for a closed crankcase ventilation. In this again we have two types. One is positive crank ventilation and one more is fixed orifice ventilation. So first we will see the positive crank ventilation system, that is PCV system. So when the engine is running, or is some unburned fuel and combustion products, okay, which will leak past the piston and move into the crankcase. So sometimes combustion product and AC emissions that will be there in your combustion due to your gap revised volume. It will sometimes it will comes to the your crankcase. So this leakage is called blow by gas from combustion chamber to the crankcase. It is blowed by. So this blow by also must remove from the crankcase, otherwise it is dangerous for the your engine. So from the engine crankcase. So how to remove it is from engine crankcase? Because if any SC will react with the oil, then it will form the sludge, then it will affect the lubrication of your engine, and there will be a major issue, it will be cost. So that has to be removed. So how to remove this remove this SC emission or combustion product from the crankcase? This is emission we have to take care. Okay. So whatever now sludge can also clog the oil liners and lubricating system. As the engine oil circulate, it also carries blow-by and some burnt particle which form the incomplete combustion of the air fuel in the crankcase. If it is not removed, this will dilute the engine oil, and hence oil does not lubricate engine properly, and wearing of the parts will take place. And filtered air from your carburetor air cleaner must be circulated to the crankcase. So air will comes over here and it is circulated in the crankcase. So while circulating from the crankcase, so what will happen? It will blow by the gases will be blown by from because it is suction pressure will be there. So this to that suction pressure, the gases whatever it is blown by. So this blown by gases and gasoline vapor from the crankcase, it will goes over here in the PCV valve. So in the PCV system, what will happen? This will again it is going fed back to the your intake manifold. From the intake manifold along with the air, again it is going to the intake manifold and again it is going to the inside the engine. So whatever the SC emission and combustion products are there formed due to PCV valve or PCV system, it is again fed back to the your system. So this is how we are maintaining our again it is blown by back to the engine. So in this way this emission can be controlled. So this is one positive crankcase ventilation system. So air is supplied, due to that it is blown by the gas and it is going to the PCV valve, then it is going inside the intake manifold. So this PCV valve will control how much amount of it has to go along with the intake manifold. So this PCV valve, whatever you are told, it consists of spring-loaded, we are saying trapped valve, spring-loaded trapped valve. The valve is closed position. Initially, it will be in a closed position. So this spring will come over here, and seating will be there. So it will be in the closed position under the action of crankcase pressure and manifold vacuum, whereas spring pressure keeps the valve open by regulating the flow of gas. Whenever the flow of gas will be there at high pressure, so this will be due to spring action, it will be open and it will comes over here. Then it is going into the intake manifold. During the idle and deceleration, that is at to low speed, amount of blow by gas is less due to less engine load and small PCV valve opening. PCV valve during the idle will be very less. Okay, and there will be a small amount of only it is passed to the crankcase. At high intake manifold vacuum moves tapered valve against the spring pressure, thus provides small opening in the valve for the flow of blow by gas. During the part load, that is normal speed engine load is higher than the idle, blow by gases will increase, so pressure will increase, that pressure will push us the spring and your blow by gases will comes over here and it is going into the intake manifold. So at high speed and normal speed, more amount of blow by gases can be passed in the inside the engine. So this is how it will works. Next one is we have the fixed orifice PCV system. Fixed orifice PCV system not there in your syllabus, so no need to take care about that one. Next, controlling the gasoline quality. How to controlling the gasoline quality? Characteristics of gasoline can be improved by adding some additives. So by adding the additives, we can control the quality of your gasoline. So good quality of gas improves following characteristics: one, the proper volatility, then resistance to detonation of spark plug, oxidation inhibitor, so that it will supply more oxygen in the combustion chamber, then anti-rust and anti-pressure, so that should not be reactive with the fuel system and avoid blocking of the fuels, then detergent to clean the carburetor and fuel injectors. Then the dice gives color for identification if any kind of leakages are there. So then it will give the identification where it will be leaked. So that will be easy way we can find out the leakages. Then the controlling of your air fuel mixture, controlling of your air fuel mixture will be very much needed so that you can control your emission, modifying the fuel system from carburetor. Now carburetor is vanished, so no need of fuel injector is placed so that emissions are much more in a controlled way. Then the faster warm up will be there. So this one will be your thermostatic air cleaner. In the thermostatic air cleaner, before that we will check the air, this one air fuel mixture. So for your ideal air fuel mixture for your SI engine will be 14.7 for complete combustion of fuel ideally. But if the fuel ratio is lower than what, then it is called as rich mixture, that is availability of oxygen is less. If it is say higher than 14.7, then it is called as lean mixture, that is availability of oxygen is excess. So as the engine mostly part on part total, this electronic circuit module will maintain the air fuel ratio near to the stoichiometric during the part totaling. Engine performance is better in the ideal air fuel mixture and produces the minimum exhaust and amount of oxygen in the exhaust is indicated by the oxygen sensor which sends signal to the ECM. So this shows the leanliness or richness of the air fuel mixture. So the ECM will adjust, that is electronic control module. Now almost all the vehicle will have the electronic control unit that will controls the air fuel mixtures depending upon your speed condition or load condition, whatever the things. So whenever the engine will warms up faster or quicker, choke will be open, so exhaust emission during the warming period will be utilized. If the carburetor supplies a cold air fuel mixture, only part fuel will be vaporized. This makes air fuel mixture lean and extra fuel will be needed. So therefore, when engine is cold or thermostatically controlled air cleaner is used for supply of heated air quickly to the carburetor. During the cold running, air entering carburetor is heated up by this thermostatic air cleaner, which allows the engine to run the linear air fuel mixture during the warm. So now we have the thermostatic air cleaner, which consists of temperature sensing spring. Temperature sensing spring will be there, which senses the temperature of air entering into the intake manifold or entering into the your air cleaner. So air cleaner, how much air temperature is there, that will senses. This air bleed valve will be there. When air is cold, this will applies the intake manifold vacuum to vacuum motor. So it will apply the pressure, so vacuum motor will in a position. So what will happen in the vacuum motor, the diaphragm and its control of arm will be the diaphragm arm will be controlled per assembly moves due to atmospheric pressure, thus blocks the snorkel tube. So this snorkel tube will be there, that is inlet for outside air, that will be blocked. So due to diaphragm movement, you can open control the air or not, or hot air inside the control, you can control by the diaphragm valve. So when the engine starts, the exhaust manifold will heat up quickly and allows the heated air to enter into the air cleaner. So heated air will comes and enter into the your air cleaner. This heated air helps into vaporizing of the fuel delivered by the carburetor or fuel injector, which then enforces the cold engine performance. So this is how you can control your air fuel mixture. Next, we have the vapor recovery system in carburetor engine, especially in carburetor engine. So if the vehicle is not fitted with the vapor recovery system, that is VRS, the gasoline vapor from the fuel tank. So fuel tank, we have the gasoline vapors. So what will happen? So it will escape to the atmosphere by operating of the breathing of the engine. So it will evaporate quickly because it is too much volatile in nature. So evaporation will be more. The fuel tank breathes with the change in temperature. As the temperature increases, the air inside the tank expands and thus forced through the either filler cap or vent in the tube. This air carries the gasoline vapor. When the temperature decreases, air inside in contact and outside air comes into the tank. This breathing of the tank causes loss of gasoline vapor or discharge into the atmosphere. So This is has to be avoided so that SC vapor, fuel vapor going inside the system, which causes the environmental pollution. So this evolution has to be avoided. So here we have provided layout of the vapor recovery system as shown in the figure. The fuel tank will be the fuel tank, then the carburetor are vented to the carbon or charcoal canister instead of vented to the atmospheric. When the engine stops, what will happen when the engine stops? Fuel will be vapors run into the tank, and a float ball will be there in the fuel tank. Float ball will be there. So this float ball enters into the carbon or charcoal or canister. This fuel vapor will enter in this canister. The activated charcoal will absorb the vapor and stores this gasoline vapor. It will absorb by the charcoal canister. Absorbs means vapors are trapped by sticking that gas vapor into outside of your charcoal. When the engine starts, the gasoline vapor in the canister is picked up by the fresh air. So when the engine starts, it will suck that gasoline vapor from the charcoal canister, then it is going inside the cylinder. Okay. So then the air flows into the intake manifold and becomes a part of air fuel mixture entering into the engine. This action is a flow of fresh air to pick up trapped gasoline from the canister is called as purging. So this mechanism is called as, this process is called as purging. The system also consists of vapor liquid separator on the fuel tank. Fuel tank we have the vapor separator, liquid separator. This chamber separates the vapor from liquid gasoline, which return to the tank. A mechanically operated vent valve or electronically operated solenoid valve may be used to control the vapor from the fuel tank. The mechanical operated by throttle linkages during the idle condition. Uh, it opens and causes the vapor to flow from the floor to chamber to the canister. The opening throttle valve, vent valve, like electric vent valve, open when ignition is off. When the ignition is on, the vent valve is closed by the energization of solenoid. So this is how you can control your vapor recovery system of your gasoline vapor from the tank. Okay. Controlling of the combustion process. So controlling of the combustion process means so many factors will comes into picture whenever the combustion we talk about combustion. So the few points I will explain over here. Combustion in the engine is a complicated phenomenon. There are a lot of chemical things will come into picture whenever you talk about combustion. The factor which affect the combustion processes are, first one is the air fuel mixture. Air fuel mixture near to the cool cylinder wall, cylinder head, piston head or piston ring do not burn whenever the cold condition is there. Whenever the engine starting condition, all the components are in the cold condition, so most of the fuel would be, whenever it contact with this cold chamber material, it won't burn. A metal surface cools this layer of below the combustion point. Therefore during the exhaust stroke, this unburned mixture of fuel swipe out from the cylinder. This adds pollution to the LC to the atmosphere. This problem is rectified by introducing stratified charge in the engine cylinder or by fuel injection method. So the other method is providing lesser surface area around the combustion chamber. A hemispherical cam has less surface area, releases less but hydrocarbon. So engine design has to be changed for this region. The second point is the combustion temperature results in a better combustion of the fuel and reduces CAC emission, CO emission, but combustion temperature, the formation of NOx will be more. So that has to be taken care. One parameter if you increase, two emission might be reduced, but one emission might goes on increases. Third point, during the part totaling, controlled advance to provided ignition distributor gives air fuel mixture longer time to burn. Under this condition, this also results in formation of NOx, but this condition that is controlled at once, which will reduce in SC and CO emission. So this device is to prevent the vacuum advance. One is the transmission controlled spark, TCS we will call, or TRS system. So this delays the vacuum advance in the neutral and reverse and forward case. And then spark delay valve. So it prevents the vacuum advance during the certain condition of vehicle acceleration. Then the fourth point is the carbon deposit present in the combustion chamber, which will absorb the air fuel mixture, and during the exhaust releases this air fuel mixture. The SC, the exhaust gas, adds the pollutants to the atmosphere. Next one is the EGR, one of the controlling technology, that is the exhaust gas circulation. I think already you know this EGR system, how it will work. So this is provided to reduce the NOx emission, especially in diesel engine. You can see this EGR valve. So EGR valve will be there, that is the exhaust, whatever the exhaust is there, that is recirculated again once again inside the your combustion chamber. So what will happen once you insert this exhaust gas along with the air and fuel mixture, the dilution effect will come into picture. So dilution, this is because of inert gas, it is dilution effect will be there. So that will comes in the combustion chamber, which will reduces the peak combustion temperature. Whenever the peak combustion temperature reduces, so what will happen, formation of NOx will be reduced. So formation of NO is reduced because of lower combustion temperature. So hence a small quantity of VGR is provided, that is 6 to 15% we can say of inert gas sent back to the intake manifold, which will reduces the combustion temperature, hence NOx formation also reduce. Also SC formation has to be reduced because whatever unburned hydrocarbon is there, again it is burned inside the combustion chamber, and so formation of SC also reduces. But formation of SC is reduced only if more amount of oxygen is available, then only it is possible. If amount of oxygen is not there, then formation of SC will increase also rather than reduce also. So this is the simplest of AGR system shown in the figure. So it consists of a passage which connects the exhaust is then to the intake. So this is passage will be connected through the EGR valve. One valve is provided, EGR valve. We can see over here also. This is O2 sensor, dual bed catalytic converter, exhaust will be there, check valve will be there. So it will come over here. So electronic control, exhaust valve. Again air intake manifold, exhaust will be there. Okay. So in the EGR, when the throttle opens, that is whenever the more acceleration is going, it moves vacuum part. This will allow intake manifold vacuum act on the foot, moves on the diaphragm to open the valve, and valve rises some amount of exhaust gas pass through the intake manifold. This exhaust gas will mixes in the air fuel, then enters into the engine cylinder, which will reduces the combustion temperature and its formation of the NOx. When the throttle valve is fully open, little vacuum is exist. Vacuum port and EGR valve nearly closed. However, EGR is needed due to rapid combustion. There is a less time for NOx emission. So most of the engine nowadays we are found this EGR valve. So some amount of EGR will be provided. So this is how it will affect on EGR. See, if it is 0%, there is, if you are not provided exhaust gas recirculation, this is the formation of NOx. If you provide 5%, see how much reduction from 3500 it is came around 2500. So much of ppm of NOx can be reduced, just 5%. 10% still it is reduced. 15% still it comes below 700, near 700 you will get 15%. So operating EGR will be depending upon operating condition around 6 to 15%. It is advisable. You can't go beyond 15%. If you go beyond 15%, what will happen? More dilution will be there. You won't get the much power. Power will be lost. More amount of SC and CO emission will be formed. Okay, so it is advised up to 5 to 15%. That's it. In this range only EGR has to provide. It should not go more than 15%. So advisably in the research it is shown that near 10% it is show better results of emission as well as in the performance parameter of your engine. Next, treating of the exhaust gas. So exhaust gas, before leaving into the atmosphere, we want to reduce the emission like SECONO. So this is done by the fresh injection of air into the exhaust system by passing the exhaust gas through the catalytic converter. So one of the thing catalytic converter will be there. So the air injection system will be there. So in this method, one of the before catalytic converter you just go through the air injection system. So in this method fresh air is air is blown into the exhaust gas very after they exist from the combustion chamber, that is from the exhaust valve in the exhaust manifold. We have to inject the fresh air. This will provide the additional oxygen. So when you are introducing the air, what will happen? The any unburned hydrocarbon or CO will be there coming out of from the exhaust manifold. It will convert it into water and CO2. SC will convert H in the converter into water. C converter CO convert into CO2. So this will reduces the pollutants. The air injection system consists of air pump, air switch control valves, and one of the check valves will be there. So when the engine is cold, air is pumped through the air nozzle in the exhaust manifold. The nozzle is located just opposite to the exhaust port, and CO2 in the air burns in the SC and CO exhaust gas in the manifold. When the engine warms up, this electronic module or the electron circuit or processor will cause the air to pass in the catalytic converter where SC and CO converted into CO2, and check valve will be passed through the avoids the backflow well of the exhaust gas into the air pump in case of backfire. During deceleration, bypass valve momentarily diverts the air from air pump to the air cleaner instead of to the exhaust manifold. This avoids the backfiring of your exhaust system. So this is how will be the valve will be there where you can control your air intake air into your exhaust. So whether the vacuum is provided is going into the exhaust manifold and the valve will be open condition, more amount of air will be there. So backfire, whenever the backfire happens, so this valve will close and the backfire can be avoided. So this is how your valve is going to operate in the air injection system, air aspiration system. Next, we have the uh, catalytic converter. One of the things nowadays we are finding in most of the cars. The function of a catalytic converter is to treat the exhaust gas and convert it into harmless gases. From harmful gas, we have to convert it into harmless gas. All the exhaust gas must pass through this catalytic converter, which is located in the exhaust system, exhaust inlet, exhaust outlet. So it is going to the catalytic converter. Catalytic converter consists of a material called catalyst. So many catalysts are provided in the catalytic converter, which causes the chemical reaction between the exhaust gas and changes its one state into the other state. So it makes two chemicals react with each other, else it will reduces the amount of HCCO in the exhaust gas. So all these gases will react in the catalyst and it will form for the less harmful gases in the outlet. So here two catalysts, different catalysts are there. One has to treat HC and CO and other has to treat NOx. The first catalyst, whatever is there, it will promote HC to unite with the degree to produce HP and CO2. So or burned hydrocarbon or CO2. So it will provide more amount of oxygen for burning of the fuel. And the second catalyst to promote your this one NOx, which will be NO or NO2. It will split into the N2. That means oxygen is eliminated from the NO, so only fresh nitrogen and oxygen will come into picture. So which will be harmless, N2 will be harmless, and O2. So in this way, chemical reaction will take place. Um, in the NO conversion, whatever the catalyst real metal, rhodium is the one of the thing they are used. So a large surface area of catalytic converter located in the catalyst. The coated surface area substrate in the form of a bed, small beds, pellets, ceramic, honeycomb. So many structure will be there. Usually honeycomb structure of catalytic converter will be useful. So a vehicle fitted with the catalytic converter in the exhaust system must use unleaded gasoline, that is lead-free gasoline. Otherwise, lead will react in this catalyst, and it will deactivate this catalyst, so which will make ineffective. So unleaded gasoline has to be used in the fuel. So this is how you can treat your exhaust gas. So this is completes your exhaust emissions. Now emission standards are there, that is bar stage 1, 2, 3, 4 and 6. Similarly Euro 1, 2, 3, 4, 5, 6. This topic is for your own way. You have to write your notes as well as you can study by yourself. Just for general knowledge, this one you should know, because most of you are having vehicles. So along with your vehicle, they have provided these standards for you. So you go through that and you make your own assignment for emission standard and you submit to me. So this will complete the module 5, entire module 5. So emissions, so general topics only is there in this entire module. So just go through this module, and any doubts you can ask. Thank you.